We now get to Chapter 4, Atomic Structure. The atom. Now, the atom is the smallest particle of an element that retains its identity in a chemical reaction. If we have an element of, say, carbon, the atom would be the smallest particle of that clump of carbon that is still carbon. Atom, as you I'm sure all know, come from the Greek word atomos, which means indivisible. So the early models of the atom, there was a chap by the name of Democritus who supposedly, if you look here and add up the ages, lived to age 110, according to this data. There are different accounts of how old he was when he died. Back then it was probably, the records weren't so great. Now he was the one who really became the first to believe that atoms were indivisible and indestructible. So you can't really get any further down than the atom. But he didn't have any proof of this. He didn't have any experiment. But he was a bright guy. He's kind of an interesting character. I guess he was a happy-go-lucky guy as depicted in this picture. I think this picture also depicts him as somewhat of a drunkard. But supposedly he was very dedicated to his studies. There's one story that he blinded himself because he didn't want to be distracted by any outside influences while he was studying. I don't know how true that is or not. But I do have to say it does have a cool outfit. Looks like he's got a drape and a Girl Scout hat on it. Always works for me. Now John Dalton took Democritus' ideas and through experimentation made them into scientific theory, and he called it the atomic theory, and it's now a theory because of the experimentation. Democritus' ideas weren't theory, and in a way it was pretty amazing that Democritus came up with these without ever doing any experiments to prove it. But John Dalton did have experiments that would prove it. So he was a pretty amazing guy. Later chapters we'll talk about other things he did, even has a law named after him, which is pretty cool. Now, there weren't celebrities like we have them today. They weren't movie stars or TV stars because, believe it or not, they didn't have TV or movie. But my guess is that the celebrities back in the day where people actually did something pretty cool, like John Dalton. So I would think when he walked down the street, people would probably come up screaming, "Oh, John Dalton," just like they would Brad Pitt. So my guess is he was the Brad Pitt of the day. Anyway, what did he say? In a nutshell, and you could read about this in your book or look in your book, all matter is composed of atoms. 2, atoms of the same element are identical. So if you have a clump of lead, all those atoms of that lead element are the same. 3, atoms of different elements are different. So the atoms of lead would be different than the atoms of silver. 4, chemical change involves the rearrangement of atoms. So if there is a chemical change, there's going to have a rearrangement, a changing of all the atoms in there. Now J.J. Thomson was really the first to discover the particles or the subatomic particles of the atom. In 1897, he did an experiment that showed that the electrons are negatively charged particles. Now, once he discovered the electron, his status probably just went up from maybe a One Direction sort of level to a Justin Bieber level. I mean, I'm guessing, I'm sure that everyone had posters of him in their house, and they were always, the ladies were always talking about him. That's my guess. But I mean, it really it was an amazing discovery. Just think about it. He discovered the electron. That's pretty awesome. Ernest Rutherford went even further. He had this really pretty cool gold foil experiment that showed evidence of what was the nucleus, what was in the nucleus, protons and neutrons. And on page 107, it goes over that experiment. how he shot a beam of alpha particles into some gold foil, which showed how protons and neutrons existed. Pretty cool. I mean, this guy was a major rock star. I'm sure when he walked down the street, everyone was screaming and going crazy. But it's pretty amazing. Now, the structure of the atom. Hopefully this is review. I'm probably pretty sure it is. But every atom has a pen in it. Every atom has a pen, meaning a proton, electron, and neutron. So let's look at that. The proton, electron, and neutron, where they're located, with their charges, and with their masses. And you will be responsible for knowing this. So the proton, where is it? Well, Rutherford showed that it is in the nucleus. The electron, J.J. Thomson showed that it is outside the nucleus, and we'll talk about where it is specifically later. The neutron is also in the nucleus, not nucleus, nucleus. The charge of a proton. Protons are positive. They both begin with P. Electrons are negative. And neutrons are neutral. They don't have a charge. Neutrons are neutral. Okay, now the proton has a symbol of P+, the electron E-, and a neutron N0 based on their charges. Now let's look at the mass of the proton, electrons, and neutrons. The mass of the proton is actually 1.67 times 10 to the minus 24 grams. And the neutron is the same, 1.67 times 10 to the negative 24 grams. The mass of the electron is 9.11 times 10 to the minus 28 grams. We can see that the proton and neutron have equal mass. The electron has about 1 over 1840 if the mass of a proton or electron. So it's relatively zero. So we're going to use something called atomic mass units instead of grams. So we're not going to use these really small numbers. Instead, we're going to use a relative mass that the proton has a mass of 1, the neutron has a mass of 1, and the electron, because it is so much smaller, almost 1/2000th times smaller than the proton or neutron, that it has a basic relative mass of 0. So the proton has a plus charge, mass of 1. It's located in the nucleus. The electron has a negative charge located outside the nucleus and no mass. The neutron is located in the nucleus, neutral charge or no charge, and a mass of 1. Let's look at the atom. Now, a penny, for example, that is composed of pure copper, has about 2.4 times 10 to the 22nd copper atoms. FYI, you'd never really find a pure copper penny anymore. I think it stopped being pure copper in about 1857 or so. In fact, it's mostly zinc now. In 1982, they switched from 95% copper, 5% zinc, to about 97.5% zinc and only 2.5% copper. So your penny is mostly zinc with copper plating. And the reason is because copper just costs too much. It'll cost twice as much. It basically costs twice as much to make a penny as than what it's actually worth. But let's just say we have a penny that is pure copper and has 2.4 times 10 to the 22nd copper atoms. Now the Earth's population has 6 times 10 to the 9th people, 6 billion people. So a penny would have 4 times 10 to the 12th more atoms than there are people in this room. So if you think of just breaking up that penny, there is going to be 4 times 10 to the 12th more of those copper atoms than there are even people in this world. That's pretty astonishing. Now, if you could line up 100 million copper atoms, they would be only 1 centimeter long, which shows you that they're pretty tiny. diameter of most atoms are about 1 times 10 to the negative 10th meters to 2 times negative 10 to the negative 10th meters. Let's look at the relative size of the atom. So if we were to think about a football field, so you have all the stands here, all the people in the stands. So this is a stadium, and here's the football field. The nucleus would be right here. So this is the nucleus. Right there at 50-yard line. And in the nucleus we have the proton and the neutron. Now the electron would be way over here at the very top of this large stadium. So we have a little dot here at the 50-yard line, which is the nucleus, and way up there is the electron. So what does that say about the atom? Most of the atom is empty space. All of this is just empty space. So everything really is mostly empty space. This kind of boggles your mind.